Hello everyone, very warm welcome to all of you. My name is Varshath Nikhila and I am working as an assistant professor at Vailtech Multitech Dr. Rangarajan, Dr. Sakundala Engineering College in the Department of Information Technology. In this video, we are going to discuss Unit 2, the native app development, which is part of the subject of app development. Then, why this unit is important? In mobile application, nowadays, a mobile application plays a major role in today's digital world. From banking to health, education, gaming, and communication, almost everything depends on mobile apps to build applications that we have to uh, capable of accessing device features. We need to understand the concept of native app development. That is exactly what we will learn in this unit. What we will cover in this video. In this session, we will clearly understand what is native app is and the difference between native app and web app, the concept of native app of hybrid app, benefits and drawbacks of native app applications, real-time use cases of native apps, tools used for native app development, Android development using Java and Kotlin, iOS development using Swift and Objective-C, and an introduction to React Native, including JSX, state, and props. So let's move to the topic. So, what is native app? A native app is a development. It is one of the most important units in application development because it explains how real world mobile apps like WhatsApp, Instagram, Google Pay, and banking apps are built. In today's digital world, mobile phones are not just communication devices. They're used for payments, healthcare, education, entertainment, and business operations like that. To achieve high performance, security, and smooth user experience, developers prefer native application. That is why this unit focuses on native apps, tools, languages, framework, and modern development approaches. Here, native app is developed specifically for one operating system. For example, Android apps means it is developed in Java and or Kotlin languages. iOS app means Shift or Objective-C. These apps are compiled directly into machine code, which allows them to run faster, use memory efficiently, and interact directly with the hardware. We have some real world example. Take Google Maps is a Google Map and is an Android app is built using Android native API. Apple Health app is built using iOS native technology because native apps are installed directly on the devices. They work even when the internet is not available. And also why native apps are fast. Native apps do not depend on browsers or intermediate layers. They directly communicate with OS kernel. Then use platform optimized libraries. Follow native event handling. So this is the result in fast screen rendering, better touch response, smooth scrolling. This is why games like AR, VR, and multimedia apps are always native. Next, the characteristics of native apps. High performance. Native apps use platform specific API, reduce processing overhead. Next, platform specific UI. Native apps users feels comfortable when Android apps look like Android, iOS apps looks like iOS. This increase trust and usability. Then full hardware access. Native apps can access biometric authentication like a fingerprint, face ID, and a camera for AR, QR for scanning, sensor for fitness tracking, like that. Then reliable and secure. Native apps uses sandboxing, app permission. So the secure storage mechanism were used in here. So there is a built-in security features are also available. Next, what is web app? A web app is accessed through a web browser and runs on a web technologies. Means web app run inside the browser. It requires continuous internet, limited hardware access. Native app, in other hand, native app is developed on, installed on devices, works offline, full device control like that. In take another example, a banking web app cannot access biometric authentication easily, but a native banking app can, like that. So native web app, uh, native web app combine web technologies, HTML, CSS, JavaScript. Then it have a native container like a web view. Then uh, it is a single code base for multiple platforms, offers near native user experience. Example வந்து Re- React Native and Flutter Ionic are the best frameworks. Then benefits of native apps. In benefits of native apps, performance wise, we take native apps are ideal for gaming, video editing, real-time tracking. In user experience, native gestures like a swipe, pinch, long press are smoothly handled. In next one is the offline capability or offline support. App stores use data using SQLite, room database, and core data like that. Then security, native app support encryption, secure authentication, OS level security patches. In performance, next one is a performance advantage. In performance advantage, we take a real example. Consider PUBG mobile game. User native rendering engines requires high frame rate, needs real time input processing, and a web app cannot handle this level of performance. In user experience, advantage, a native app provides a faster response to touch, smooth animations, platform consistent navigation. Users subconsciously trust apps that feels native app. Next, device features. Native apps can integrate AR, means augmented reality, fitness tracking, smart devices like IoT, payment gateways. Example, Google Fit uses sensors. And Uber uses GPS continuously, like that. Then offline functionality. Native app store, user data, catchy content, app preferences. So this is essential for rural connectivity areas like travel apps, educational apps like that. And the drawbacks of native apps, it requires a higher cost for development. It separates team for Android and iOS like that, and it take a longer time to develop because it has a two different code bases for Android and iOS. Then maintenance capability, complexity. In maintenance complexity, it needs to fix the bugs, must be applied twice. Despite these drawbacks, native apps are still preferred for critical system. When to choose? When to choose? To choose native app development. Choose native apps when performance cannot be compromised, security is mandatory, then device features are core functionality, then long-term scalability is needed. In real-time use cases, banking, in real-time use cases, we'll took a first one is banking. In banking apps, it needs a security and biometrics. In gaming, it needs a graphics performance. In healthcare, sensors and real-time monitoring. Enterprise workflow automation. Like for these purpose, we use native apps. Next, tools for native apps development. Android Studio, Java, and Kotlin support for developing Android Studio, Java or Kotlin emulator and debugger. Then for Xcode, Shift UI previews, performance monitoring. These are used in for creating native apps. Then programming languages like Java. For in Android Studio, programming languages, Android Studio. Android for Android development, the official ID is Android Studio, the complete integrated development environment for building Android applications. Key features like support it supports Java and Kotlin, advanced code editor, built-in emulator, debugging tools, and Gradle build system. Next, the Xcode. Xcode is for official IDE for iOS development. Apple's integrated development environment for Mac OS, iOS, Watch OS, and TV OS apps. Key features in this was it is supports Shift and Objective C, interface builder, iOS stimulator, performance profiling, Shift UI preview. Next, the popular frameworks for native app. React Native, Flutter, Xamarin, NativeScript, Ionic, KMM. These are the popular framework of native app development. Java for Android app development. Traditionally and widely used language for Android app development is Java. Or it is object-oriented programming language, strong and mature ecosystem, large community support, widely used in legacy Android apps, extensive documentation and resources. Kotlin for Android development. Kotlin is a modern language officially supported by Google since 2017 for Android development. The key features in it, it is null safety building, concise syntax, full Java interoperability, coroutines for async, then extension functions. Shift and Objective-C for iOS. Objective-C is base. It's old one. We used previously. Then these are the differences between Objective-C and Shift. Then introduction to React Native. React Native is an open source framework by Facebook for building across platform mobile apps. Key benefits, it uses JavaScript and React single code base for iOS and Android, near native app performance, large community and ecosystem. Basics of React Native. Components, we use reusable components, UI components, native UI, hot reload, and community support. JSX. JavaScript XML is the syntax extension that allows writing HTML like code within JavaScript. State in JSX, state stores dynamic data that can change during component life cycle. Key concepts like it stores dynamic data, data changes over time, state update, re-renders UI managed via use state hook or set state. Then props. Properties pass data from parent to child component in JSX. The key concepts is It is used for short properties, pass data to components, read only, and enable reusable components. So this is the difference between state and props. Developing Android app using Java. First, we have to install Android Studio IDE, create new project, a new Android project, design UI using XML layouts, and write Java business logic. Then test using emulator or physical devices. Then build and publish app to Play Store. So these are the takeaways. Performance of native apps delivers best performance and user experience. Android, Java, and Kotlin are primer languages. In iOS, Shift and Objective for Apple. Cross platform, React Native enables a single code base for both platforms. Core concepts like JSX state props are fundamental to React Native. Thank you.